Okay, continuing with the Chapter 2 review, this is Part C, um, and we have a given conditional statement. If AM equals MB, then M is the midpoint of segment AB. First thing I want you to do is take that conditional statement and decide if it's true or false, and if it's false, provide a counterexample. So we'll look at a few examples, and I'll draw them out. If AM equals MB, so let's say this is point A, point M, and point B. If the distance from A to M is, say, 7, and the distance from M to point B has to be equal, is M the midpoint of segment AB? And the answer is yes. So by one example, it looks like it's true. Okay, if we change the distance from A to point M and the distance from M to point B to be something different, it still appears to be true. For example, if we said distance from A to M is equal to, say, 12 centimeters, and the distance from M to point B is 12 centimeters, M still looks like it's the midpoint of segment AB. So it still seems to be true. But any number of examples never proves something to be true, because we can prove something to be false if we can come up with one counterexample. So therefore, the counterexample is going to look like this. I'll draw it off to the side. Distance from A to M is going to be, say, 8. And the distance from M to point B is going to be the same, equal, it's going to be 8. Is point M the midpoint of segment AB? Well, segment AB is this orange segment. Point M is not even on that segment. So therefore, point M is the midpoint of segment AB is a false conclusion. It's an inaccurate conclusion. So the statement is false. Just because the distances are equal doesn't make point M the midpoint. So we state false, and we provided a counterexample, the diagram over on the right. Now, to continue on a set of problems like this, I like to then immediately state the true and false part to the contrapositive down the bottom in this case. The original statement and the contrapositive are always going to be logically equivalent. So if one is true, the other one has to be true. If one is false, the other one, in this case the contrapositive, has to be false. Likewise, when we state the converse and the inverse, if one of those is true, the other one has to be true, and if one is false, the other one has to be false, so they are logically equivalent. So whatever you state for the answer for the true and false part of the converse, it has to be the same answer for the inverse, whether that's true or false. They are logically equivalent. So we'll continue. The next thing we have to state here is the converse. The converse is going to be an if-then statement. So the converse is going to start with the word if. It's going to be a conditional statement. You don't have to state it in if-then form. And it's going to have the word then in it. The difference between the given statement and the converse is whatever was the conclusion for the given statement is now going to be the hypothesis for this statement. So that is, in this case, M is the midpoint of segment AB. That was the conclusion of the original statement. It's now the hypothesis of the converse. And likewise, whatever was the hypothesis of the original statement is now the conclusion. So that is AM equals the distance from M to point B. And we have the converse completed. So now we have to decide if that's true or false. And in this case, the sentence is, if M is the midpoint of segment AB, then the distance from A to M equals the distance from M to point B. Well, that's just stating part of the definition. The other part of the definition also concludes that M is on segment AB. But to say that the distances are equal, there's nothing wrong with that, so therefore this is true. That's justified by the definition of a midpoint. So like I stated a few minutes ago, if that statement is true, the inverse is going to turn out to be true, even though we haven't stated that yet. The next thing I like to continue with is to state the contrapositive. So the contrapositive is going to be a conditional statement. I'm just going to get rid of some of this scribble, and I'm going to say that is a conditional statement. So I like to state all conditional statements in if-then form. The new hypothesis is going to be the original conclusion, M is the midpoint of segment AB, negated. So we're going to say if M is not the midpoint of segment AB. So notice we inserted the word not. Now if the original sentence has the word not, you're going to remove it. You're not going to make a double negative out of it. Or if they're unequal, if something's unequal, you're not going to say not unequal, you're going to say equal. You're going to state the negation. And the new conclusion is going to be the original hypothesis, AM equals MB, also negated. So I'm going to say AM is not equal to MB. And that is false. Why? Because if M is not the midpoint of segment AB, I could draw a diagram like this. M is obviously, M is definitely not the midpoint of segment AB. It's not even on segment AB. But it is possible that it's equal in length, such as this distance could be 8 and this distance could be 8. So I satisfied the given information. I drew something that had M that is not the midpoint of segment AB, but I ended up drawing a diagram where the values AM and MB were equal. So therefore the conclusion, they have to be different, is inaccurate. So therefore that statement is false. And now that we've done that, I like to go back to stating the inverse, the only part left to this problem. And the inverse compared to the converse is the same as the original statement compared to the contrapositive. It is also an if-then statement. And the inverse is the contrapositive of the converse. So that means I want to take the converse conclusion and negate it and make that the new hypothesis. So AM is not equal to MB. And then M is not the midpoint of segment AB. If they're not equal, it's definitely not a midpoint. Okay? If it's on the segment and they're not equal, if it's not on the segment, if 3 points are not on the same segment and those two distances are not equal, if it's not on the segment, it obviously is not the midpoint. But if it is on the segment, if the distances are not equal to each of the two endpoints, point M can't possibly be the midpoint. So that statement is true, just like the converse being true, because they are logically equivalent. You know one's true or the other one's true because you know what the word midpoint means in each case. Hopefully this helps. Good luck.